since angle W is identified as a right angle, that means it's 90 degrees.
Good. We know that angle W is 90 degrees.
And it has 4 sides, so that all the angles together should measure up to 360.
Good. So n equals 4. So we're going to do n minus 2 times 180. And so exactly what you said, it is 4 minus 2, whoops, times 180 gives us 360. Okay, go on.
Oh, I did it a different way.
How'd you do it?
I added W and Z together and subtracted it from 360.
Okay, so you did 360 equals 90 plus 120 plus angle X and angle Y. And then 90 plus 120, you got 210?
And so I just divided, I divided 210.
You subtracted 210 from 360?
Oh yeah, afterwards.
Mm-hmm.
I subtracted 210 from 360.
And you should have gotten 150 equals angle X plus angle Y. Now, what's so special about X and Y, guys?
They're two angles.
Yeah, but what's special about them? Because right now, we can't, how do we solve this?
We divided 150 by 2.
We divided 150 by 2, very good. But why?
Because there's 2 angles.
There's 2 angles, but what's so special about X and Y? They're congruent. How do we know that they're congruent?
They're marked as equal.
They have the mark, very good. So X and Y need to be the same. So you just can write this, let's assign a variable to them. Let's assign little x to both of them, okay? So little x is gonna be both of those angle measures. So this would technically be 150 equals little x plus little x, which is just 2 little x. So 150 equals 2 times little x. That's why we divide by 2. And we're gonna get 75 equals x. So the measures of X and Y is 75 degrees. Very good. Okay, number 7, what did you guys get? Oh, you're still working on 7?
Yeah.
Well, how many sides does that figure have?
6.
Mm-hmm. So how much should all the angles inside be? Should be 6 minus 2 times 180. This will give us 4 times 180, which is 720. So we know that all of the angles inside this hexagon should add up to 720 degrees. So 7. What'd you get?
X equals 180.
Nope. Close though. So let's just follow along, Teresa, see if where your adding went wrong. Okay? So we got 720 equals. We're gonna add all of the angles together inside. So we've got angle X plus angle Y plus 108, which is angle Z, plus 149 plus oops, 149 plus 103 plus 90, because this is a 90-degree angle. So we're going to get 720 equals the square, I'm sorry, not the square root, equals angle X plus angle Y plus, if we add all four of those angles together, you should get like 450. We subtract 450 from both sides. We're going to get 270 equals angle X plus angle Y. What's special about X and Y? They're congruent. So we can write it in as 2 times one angle. So let's make these A and A. We're just assigning a variable to them because we know that they have to be the same. So this is going to be 270 equals A plus A. So we've got 270 equals 2A, divide by 2, divide by 2. And we know this is going to be 135 equals A.
Hold on, please.
Mm-hmm. Teresa, does that make sense?
Yeah, I just didn't add 90. I didn't include it. I forgot.
Oh, okay.
Yeah.
Okay. That makes sense because then, yeah, you should have gotten 45 degrees more than 135. So that would have been 180. Mm-hmm.
Where did you get
A. So all I did, Juliana, you could have assigned anything to represent A, X and Y. But I just assigned any variable. This could have been X, this could have been Z, this could have been Y. But you could have picked whatever you want to represent X and Y. Go ahead, Kale.
I'm joining on another device.
Okay. What was the other question?
I have a question.
Yeah.
So the way I got the same like answer, but when I set it up, I like set it up differently, and I don't know if it makes a difference.
How'd you set it up?
What I did was X plus 90 plus 149 plus 108 plus 103 equals 720.
That's perfectly fine. As long as the key here, guys, is for you guys to recognize that this angle X and angle Y should be the same. So if you, from the get-go, represented them by like X's, so you put X plus X, that is perfectly fine, okay? But you need to represent them using the same variable because they're going to be the same measure. So in my case, I used A at the end. You could have used A from the start. You could have used X from the start. Whatever you guys wanted, but you needed to recognize that they were going to be the same measure, okay? Does that help, Teresa?
Yeah.
Okay. Awesome. Anyone need more time to copy this down? All right, let's do this. Okay, Chapter 7, Section 2. Guys, just a heads up, I apologize in advance. For some reason, when these slides printed, they didn't print very well. So we're going to have to draw some of the diagrams, okay? But this is Chapter 7, Section 2, Properties of Parallelograms. Parallelograms. A quadrilateral with two pairs of parallel lines is a parallelogram. To write the name of a parallelogram, you use the symbol. And this is an example of where things didn't copy very well. Go ahead and write in there this symbol. That is the symbol for a parallelogram, okay? It's two horizontal lines above each other and then two slanted lines that are parallel, okay? That is the symbol for a parallelogram. And you guys will see it either written as parallelogram ABCD or that symbol for parallelogram and then the letters ABCD, okay? Now, It's called a parallelogram because we have two sets of parallel sides, okay? So AB is going to be parallel to CD, and BC will be parallel to DA. All right, guys, is a square a parallelogram?
Yeah.
Yep. Is a rectangle a parallelogram? Yep. Is this figure, oops, a parallelogram? No. Okay, that's just a regular quadrilateral. In order to be a parallelogram, you have to have two sets of parallel sides. I would say that in this figure, none of these sides are parallel to each other, okay? All right, moving on. There are some really cool theorems that we get from parallelograms, okay? The first theorem is that the opposite sides of a parallelogram are congruent. So those sides that are parallel to each other, for example, BC and AD, they're also congruent. They're going to be the same length. Same thing with AB and CD. Since they're parallel, they're opposite each other, they are also going to be the same length. That's the first theorem. There's 4 of them in total, okay? So for parallelograms, the opposite sides, the sides that are opposite each other, are congruent. They're the same length. The second theorem, the opposite angles theorem. So opposite sides are congruent, opposite angles are also congruent. So in our image, right, we've got angle B highlighted in blue. That one's going to be congruent to angle D, which is highlighted in blue as well. They're opposite each other. Angle A and angle C will also be congruent because they're opposite each other in our parallelogram. David, you already got it? I still don't want you doing whatever you're doing, okay? Next one.
Thank you.
7.5 and 7.6, the parallel consecutive angles theorem and the parallel diagonals theorem. The consecutive angles theorem says that if there's two angles and they're next to each other in a parallelogram, they're supplementary. In other words, if you add them together, they equal 180. So, let's take angle A, for example. Samantha, what's an angle that's next to angle A? B. A plus B should equal 180. What's the other angle that's next to or consecutive with angle A? D. Angle A plus angle D should equal 180. Okay? Same thing for C, same thing for B, same thing for D. The two angles that are next to any angle should add up to 180 degrees. The parallel diagonals theorem. Remember, a diagonal goes from one vertex to the other non-consecutive vertex. In a parallelogram, there's only going to be two diagonals. What's so special about the diagonals is that they bisect each other, okay? So point Z is the intersection of the two diagonals. And what's so special about point Z is that it cuts BD into two equal parts. And it cuts AC into two equal parts. So we can say that BZ is congruent to DZ and AZ is congruent to CZ. That is the parallelogram diagonals theorem.
On the other slide, was there anything under
Yeah, I'll hold on here. So there's 4 things that we need to know about parallelograms, okay? Opposite sides are congruent. Opposite angles are congruent. Angles that are next to each other are supplementary. And our diagonals, where they intersect, they bisect each other. So they cut each other in half. Okay, guys. You good, Marcos? Oh, I'll hold on. Anyone else still copying? Or can I move on? All right. On your next example, okay, so this is an example, sorry guys, where it didn't print out correctly. So first, underneath example 1, I need you to write, given that ABC is a parallelogram. So given that A, B, C, D is a parallelogram. And number 1, part 1 of example 1 says name all pairs of parallel lines. Well, before we do that, guys, we're going to copy down our figure so it looks more like a parallelogram, okay? So I want you over here on the right to just draw the same figure, just a little bit different. I want you to draw it like this. So CD and BA should be at a diagonal. This is B, this is A, this is D, this is C, and then we've got 2 lines that go across. Those are the diagonals. This is point E. Okay, so we're working on the pairs of parallel lines. If this is a parallelogram, A, B, C, D, which sides are parallel?
B and DC.
A, B, and DC, good. AB is parallel to DC. What else is parallel?
AD is parallel to BC.
AD is parallel to BC, very good. AD is parallel to BC. Anything else is parallel? No. What were you going to say, Noah? You just realized what? Yeah, there's only 2 sets of parallel sides. There's nothing to do with those diagonals that will make anything parallel, okay? So we got 2 pairs of parallel lines, okay? That is the definition of a parallelogram. Now we need to name all pairs of congruent angles. There's a bunch, okay? So I'm going to list all of these in red. All the pairs of congruent angles, okay? So we're going to answer number 2 down here because we're going to need space. Remember to use 3 letters when we're identifying angles for this problem. Okay. Let's see. What do you guys think are congruent angles?
Angle BEA is congruent to CED
Beautiful. Why?
because they share the middle, which is E, so that makes them congruent.
Good. So CED is congruent to BEA. That's this one and this one. Why? Because they're vertical angles. All right, guys, help me out. Give me another set of congruent angles.
BEC is congruent to AED.
Beautiful. So these 2. What's your reasoning? Mm-hmm. Beautiful.
Has an angle.
Yep. They're vertical. What else? Now let's start thinking about parallelograms. Which angles are congruent in a parallelogram?
Angle D and angle B.
Ah, okay. You're on the right track, D and B. But remember, we can't just call them D and B because there's that line in between them. So we need to use 3 letters. Let's try that one more time. Go ahead, Samantha.
Can we do ABC and ADC?
Yep, very good. So angle ABC is congruent to angle ADC. Awesome. And why are they congruent? They're opposite angles of a parallelogram. Okay, so that's one pair. A, B, D. 1, 2, 3. 1, 2, 3.
BCD is congruent to D and B.
Good. 1, 2, 3, 4. Angle BCD is congruent to, you said BAD?
Yeah.
BAD. Awesome. Why, Teresa?
Because they're opposite angles
Mm-hmm.
of a parallelogram.
Beautiful.
Can I go to bathroom?
Yep. Opposite angles of a parallelogram. Okay, guys, this is where it gets a little tricky.
Can we go back to the answer for number 1 of this example?
Yeah. Mm-hmm. Okay, guys, let's say I give you angle BAE. Has to be congruent to another angle in this figure. What would you guys tell me?
CED.
CED. This one?
Yes.
Not quite. Close, though. Not quite.
DDE.
BDE. That's a line. Those are all on the same line.
C?
DEC. This one? Let's think about it. Imagine that this diagonal is a transversal. And this is parallel to which line? AB is parallel to which line? DC. So imagine we have two parallel lines cut by a transversal. Does anyone see it now? BAE is going to be congruent to DCE. Okay? Those two will be congruent. DCE. Because they are alternate interior angles. The ones in black, guys, I'm only going over in the notes. You guys don't need to know this for the test, okay? I just want to make sure that if, like, you guys understand it, okay? But you don't need to know this for the test. Let's take DAE. This one. DAE. What angle do you guys think should be congruent to DAE?
BAE.
BAE. This one?
Or
Yeah.
CAE.
No, CEB.
CEB. Nope.
CBE.
CBE. Close. Close. BCE. There we go. BCE. Awesome. Okay. Alternate interior angles.
I can't see what you wrote on the bottom.
Oh. Just put a note here. Do not need to know for the test. Okay? But these two, yes, 100%. Okay? Those two, or those four, yes, you need to know. Because we know about vertical and we know about opposite angles of a parallelogram. The other two, the alternate interior angles, are a little bit more complex. Okay? There's two more pairs of alternate interior angles, with BD being our transversal. And those angles are ADE would be congruent to CBE and CDE would be congruent to ABE.
Do we also not need to know that, or do we need to like?
That's also part of what you don't need to know
Alright.
for the test. Okay, guys. Example 2. In example 2, what we are doing is we are finding x, y, a, and b, given these parallelograms. So STU is a parallelogram. We got to find x, we got to find y, we've got to find a, and we've got to find b. Okay? In A, go ahead and put an A down here. There should have been an A between U and T. What's x going to be?
80,
It's going to be 80 degrees. Why?
because it's
It's a parallelogram, and the opposite angle is 80. Okay? What do we know about y? It's across from what?
U.
Not U. It's opposite T.
Oh, you
What do we know about angles that are next to each other in a parallelogram? What's that?
They're equal.
Nope. If they're across from each other, they're equal. If they're next to each other, it's that third theorem. If two angles are next to each other in a parallelogram, so y is next to x, they're going to add together to give you 180 degrees, okay? So y plus x equals 180. We know that x is 80, so this is y plus 80 equals 180. And we just subtract 80 from both sides. We're going to get y equals 100. So this one's 100, this one's 80. What's a going to be? 6. And what's b going to be? 9. Because remember, if your opposite sides of a parallelogram are always equal, and your opposite angles of a parallelogram are always equal. We're going to skip b, but we are going to do c. But we're going to need to rewrite c a little bit, okay? So over here on the right, I want you guys to rewrite c as a better parallelogram. And this is 3y plus 4, 4x, 8, and 13. And this should be R, S, T, and U. How do we solve for x, guys? Set 4x equal to 8. So x is 2. How do we solve for y? Yep. 3y plus 4 will be equal to its opposite side, which is ut, 13. So we're going to subtract 4 from both sides. We're going to get 3y equals 9. Divide by 3 to both sides, we get y equals trace. Awesome. We're almost done. Example 3. Find the perimeter of, go ahead and put parallelogram in there, a parallelogram symbol, PINE, if PI equals 12, IN equals 8. Well, we're not given a figure, so I always like to draw one, so I'm just going to draw a nice little parallelogram. And I'm going to label it P, I, N, E, making sure that my letters go in order as I move around the parallelogram. Okay, so PI, which is the distance up top, is 12, and IN is 8. What are my other sides? What's the size of EN? 12. And PE? 8. So what's the perimeter going to be? I heard it. It's 40, okay? It's going to be, 12 plus 8 plus 12 plus 8. Adding all 4 of the sides together, and we get 40 units. Okay? Some people in my last period were like, well, Mr. Yurko, if we know 2 of the sides, we just multiply each of them by 2, and we add them together. You could have absolutely done it that way. You would have gotten 12 times 2 is 24, added it with 8 times 2, which is 16, and you would have gotten 40 as well. Because you know for a parallelogram, you have 2 sides that are congruent, 2 pairs of congruent sides. All right. Example 4, we're going to skip, but we are going to do example 5, okay? 3 vertices of parallelogram W, X, Y, Z are W is -1, -3, -2, -3, 2, and Z is for -4. Find the coordinates of vertex Y, okay? So we've got to plot these. You guys, I recommend that you guys use graph paper for this one, okay? I don't have any using what explain everything, so I'm going to do the best that I can. I'm going to draw a y-axis, an x-axis, and I'm going to plot these points. So W is at -1, -3, so left 1, down 3. This is W. X is at -3, +2. X. And Z is at 4, -4. So 1, 2, 3, 4, down 4. Okay. W, X, Y, Z. W and X are next to each other. Z is also next to W. So Y is going to lie.
Is there like a air pump case here?
A SpongeBob one? Yeah, it's right here.
Thank you.
You're welcome. Okay. So, Y is going to lie somewhere over here, okay? But we don't know exactly where Y is going to lie, okay? The line segment ZY should be congruent to which one? XW or WZ? What do you guys think? If Y is somewhere over here. XW, okay? So it has to be congruent to XW. In order to find that, we need to find the slope of XW and draw the exact same line from Z, okay? So the slope of XW we went down 2, 3, 4, 5, down 5, and we went to the right 1, 2. So our slope is -5/2. So all we're going to do is do the same thing from Z. So the slope of ZY has to be -5/2. They have to be the same. Which ones?
W, X, Z, Y.
What do you mean?
Oh, never mind. My mistake.
No, no, tell me.
I thought you swapped, when you were finding the slopes, I thought you swapped the two by mistake.
Oh. XW. I think it looks okay.
Yeah, you got it right.
Okay. So from Z, we're going to rise 5. So 1, 2, 3, 4, 5. And we're going to move to the left 2. So Y should be right here at 2, 1. If we complete our figure using this image, we should get a parallelogram that looks nice and parallel and with all the sides congruent. If you did it right on your page, you should get a figure that looks the same. So here we went plus 5 minus 2. 5 over negative 2 is the same as negative 5 over positive 2. This is the toughest part of this lesson, guys.
Are we gonna need graph paper for the test?
Yep.
So are we done now?
Yep. You guys